Hello everyone, welcome to my channel again, and this time we are going to go to the third part of our series, which is energetics. So yeah, I'm pretty sure I hope you all enjoyed the first two parts, and yeah, if you have enjoyed them so far, please subscribe. Yeah. Okay, so in energetics, well, it is a bit less done compared to titration and QA, I guess. It doesn't really have a huge part compared to the other two. And generally, it tends to be lumped together with kinetics, like you would do a kinetic and experiment that involves energetics in it, because I think it could be because energetics shares common ground with physics, and you may end up doing energetics experiment in physics for all that you know. But yeah, I think that's my opinion. So generally, the energetics and the kinetics experiments tend to be pretty quick, unless you do something really stupid and have to do extra experiments and stuff like that, and I'll talk a little bit more on that later. So in energetics, you usually measure the temperature change because you want to measure enthalpy change, right? So if in order to measure that, the easier thing to measure is the temperature change. So in this case, you have to worry about the thermometer sensitivity, and in that sense, here's one place where you could waste time because if sometimes the thermometer doesn't move very quickly, like the level of the alcohol or the mercury or whatever they use doesn't move very quickly. So sometimes you may not know, oh, is this the highest temperature or is this the lowest temperature? Will it change anymore? So in this case, I suggest instead of waiting forever and like making confirming that this is definitely the highest or lowest temperature, once you realize that it doesn't change very quickly anymore, you should probably just take note of it and go on. Like you can do something like this. You can like count for 5 seconds, and if it doesn't change at all after that, then you can just take that as the highest or lowest and move on, because sometimes if you overdo it, you will waste a lot of time. And I'm pretty sure I have done that before, so I don't think you want to be doing that too. So yeah. So the next thing is sometimes you'll be using hot water, which comes from this big boiler thingy that boils the water to like not really boil, but bring it up to 90 degrees Celsius. And of course, be careful with the water. I don't think I need to belabor this, but be careful. And you know, you can hold your measuring cylinder with the beaker with a cloth. You know, the cloth that you have in the sink. You can use that to hold it. So there's one thing that really comes to mind when I talk about this, which is sometimes we need to bring the water to a more reasonable temperature, which is like maybe 50 degrees or even 40 degrees. And sometimes I'll take quite a bit of that 90-degree water, and then I just pour some of the room temperature water and expect it to become 50 degrees. But in the end, it's only like still 80 something degrees, and I keep diluting it with more and more room temperature water, and it takes forever to get it to 50 degrees. So do take note of this when you know you're actually doing the experiment, and you know, don't use too much of the hot water when you're trying to bring it to 50 degrees. It's easier to make it hotter than to make it colder in that sense. So yeah, and actually I think maybe there's a reason why the temperature change can be slow sometimes, which is because of the high heat capacity of water. And therefore it tends to cool down a little bit too slowly for that matter. So yeah, just take note of that when you're doing the experiment and try not to waste too much time. Maybe you can do other things while waiting if you don't have to take temperature readings too many times or something. You can you know, do some multitasking. Yeah, so apart from that, the energetic experiment tends to be somewhat graphical in nature. So before you even start with all each of your experiments, if you need to draw a table, please do that. And actually I forgot to set this in the titration one, but always write, like, draw your table before you start your experiment. It helps a lot. And if you're the kind who need to erase and rewrite it, even if you have your table, you can write your values on the side in pencil and then later on write it in pen in the table. I think that may help for those who like to, write in pencil, then erase, and then write the actual thing that you want to write, your bluff values maybe, in pen. So yeah, that's what I would like to say. So another thing about the graphical nature is that sometimes they will give you like maybe 2 points and ask you to do three other experiments, maybe to see which amounts of reagents will give you the highest temperature. And in order to do that, you had to plan it properly. Don't end up, you put two temperature points that are too far apart, and then you don't really know where the midpoint is, even after three experiments. So try to be a bit sensible about it. So for example, if you have 2 points that is in maybe okay, let's say between 20 and 30, and one would be in maybe 22 and one is in 27, then you have three other points that you can do. I guess you can do one that's in 25, and no, actually, I guess maybe the 2 points given would be somewhat more further apart from this. So your 3 points may be 22, 25, and 27. And sometimes you're unlucky and you actually need a fourth point. So just be prepared. And since if try to avoid that situation, and if you really, really do not have time to do another experiment, just bluff the results. Because you already have 3 points, you might have a general idea where the optimal point is. So yeah, but I think it's better to do the experiment than to bluff it, because bluffing it may cause a lot of accuracy loss in terms of your experiment. But if you really, really do not have time, I think you can just bluff. So yeah. So I'm pretty sure you heard of this thing with the calorimeter, and I feel like that is very rare. You may not really get to do that, the A levels. Maybe you're more likely to do it in planning, or you may see it in your physics practical instead, which, yeah, I think is more likely to come in the physics practical for some reason. So yeah, I think as with every part of the practical, you do not want to be taking too much time in energetics or your kinetics experiment. I'll talk about kinetics next time. So make sure to allocate about 20 to 30 minutes for each part of your practical. So including this, I guess. And yeah, I think that's about it. Next time I'll be talking about kinetics, and maybe afterwards I might talk about planning, or also talk about the entire practical in general, like the whole procedure, if you are willing to listen to it. As with every other episode in this series, if you have a lot of questions on this, or there's a lot of, if you want me to talk about other suggestions, or go into detail, you can write it in the comments below, and I make a video 3.5, for example, for this one, and cover those questions. And if you like this video, please press the like and subscribe. Hey, thank you.